Find the proportion of area under the normal curve to the left of z equal negative 0.53, which means less than a z-score of negative 0.53. Visually, this is what we're looking at. We've got z equals 0 in the center, z equal negative 0.53 to the left of center, and the area left of z equal negative 0.53 is all the area shaded down towards negative infinity from the left of negative 0.53, all this area. Okay, so on our calculator to do this, we still need to use a lower limit and an upper limit, but this time we're going to make use of negative infinity. Now, negative infinity is going to be our lower limit because it's on the left, and negative 0.53 is going to be our upper limit because it's on the right. So going to your calculator, lower is going to be negative 100,000, that represents negative infinity. Upper, negative 0.53. Mean is 0, standard deviation is 1, and then go down to paste. And you should get 0.2981. This is all of the area to the left of negative 0.53. Every time we want to find the area between two z-scores, or to the left of a z-score or to the right of a z-score, we're always going to use a mean of 0 and a standard deviation of 1. Okay, that's going to be the case every time we do normal CDF between z-scores. Okay, 0.2981. Find the proportion of area under the normal curve to the left of z equal 2.56, which means less than a z-score of 2.56. So looking at a picture of the bell curve, in the center we have z equals 0, then we have z equal 1, and for reference z equal 2, and note that z equal 2.56 is a little bit to the right of z equal 2. Okay. Anything to the left of z equal 2.56 goes from this location all the way down towards negative infinity. All of the area under the bell curve down to negative infinity. So to do this on the calculator, to find this piece of area, we have to use our lower limit, which is going to be negative 100,000. Our upper limit is 2.56. Our mean is 0, and our standard deviation is 1. Okay, so we always want to remember the lower z-score is the lower limit. So negative 100,000 is always going to be the lower limit for a question like this, where we have to find the area to the left of a z-score. And 2.56 is going to be the upper limit because it is the higher of the two z-scores. So when you calculate that, you should get 0.9948, almost all the area of the bell curve. So maybe our picture is not entirely accurate. It's okay. It's just there to show you a representation of what we're trying to find. We're trying to find the area to the left of 2.56. Okay, so the proportion of area under the curve to the left of z equal 2.56 is 0.9948. Okay, a couple more problems just to get the hang of this. Let's find the proportion of area under the normal curve to the right of z equal negative 1.37. To the right, which means greater than a z-score of negative 1.37. So let's make our bell curve, and let's note where negative 1.37 is. It's to the left of 0. And the area to the right of negative 1.37 is all the shaded area that's going up towards positive infinity. Okay, so our z-score on the left-hand side is negative 1.37. Our z-score on the right-hand side is positive infinity, 100,000. So on our calculator, we're going to put in negative 1.37 for the lower z-score, 100,000 for the upper z-score, a mean of 0, and a standard deviation of 1, and hit paste. And you should get 0.9147. So the amount of area, or the percentage of area under the bell curve to the right of negative 1.37 is 0.9147, or 91.47%. Find the proportion of area under the normal curve to the right of 0.67. Okay, so we label again, z equals 0 is in the center, so 0.67 has got to be to the right of that. The area to the right of 0.67 is everything from 0.67 up to positive infinity. So the lower z-score is 0.67 and the upper z-score is positive infinity. So we put in lower 0.67, upper 100,000, mean is 0, standard deviation is 1, paste it, and it is 0.2514, 25.14%. Okay, so hopefully that gave you enough practice using normal CDF on your calculator to find the percent of area between two z-scores. And you could also do that involving area all the way to the right to positive infinity and area to the left to negative infinity. The last thing we're going to